Hi, I'm Gospel Eze and this is another video on Mathbuilder. Last week we released steps and description. Steps was simply a way for you to understand what each node is doing and what each operation is doing. So the way I like to see it is that it takes you on a journey from the beginning of the computation down to the outputs that you're trying to inspect or the output you're trying to understand better. And we also released description. Description is simply a way to understand what's happening on the flow, right? And description is so good that you could even have like a full-on article because we support Markdown. You could have code, you could have math, which is latex, you could have embedded links, embedded videos, and what have you. So that got released last week. But this week, I'm happy to share we've released 4 new input types: vectors, linears, quadratics, and polynomials. These are 4 new input types to help you do more with Mathbuilder, right? Like I said, from day one, I'm trying to make Mathbuilder the best computation tool that I would use and I would love even you to use. So that will release today. And also, I'm going to show you a demo in a bit, but then I also want to show you a feature we've had from the beginning, which is called type mixing, right? It's not necessarily a feature, but just something that is implicit, right? Meaning that you could mix types, you could add something that you would expect not to actually work, and it would actually work because we don't restrict you to what you can do. We only show you what you have done and try to lead in the right path. Let's go into the demo.
So let's check out vector first. This is a simple vector. This is the dimension. You choose the dimension. You could choose 2, 3. So let's use 3. Let's try to compute vector addition, or rather, let's do dot product, which is a more interesting operation. So dot product, going to get another vector. Let's make this a bit smaller. So we have this. So let me add some values. So you see, this is the dot product of these two vectors. So yeah, so we have other operations for vector. We have vector addition, we have vector subtraction, and then we have the norm, which is simply the magnitude. So just a quick description. A norm is a generalized version of a magnitude. So when you're working with certain other systems or certain field, or yeah, a norm is a generalization of what you would call a magnitude. So yeah, you see it's calculated norm of this. And then this is a bit about the what I talked about earlier about mixing. So this is it's trying to find the square root of 26. Now that would throw error because 26 doesn't have like it's not a perfect square, right? So it just gives you like this. So you could also compute on this. It doesn't stop here. So I can actually try to say um adding, actually I can add these two values. So 27, and say 27 plus the square root of 26. It gives you like this value, right? It doesn't restrict you just because it couldn't compute it. So it just keeps using it. And over time, you can actually try to simplify to something smaller. But yeah, let's go to the next. So let's work on polynomial. So this is a polynomial. Let me make it a bit bigger. So you choose the degree. So let me make it degree 3. So let's add a constant. Now let's do polynomial. Let's try polynomial addition. So let me get another polynomial. So now a bit about the mixing I talked about earlier. All these operations are the same operations you would use for a decimal. Now, why don't we have polynomial addition? Because we don't want to restrict you, right? Because we know these types can actually work together, right? We just want you to experiment with it and be expressive about it. So you don't have to be like, oh, we have polynomial addition or something else, right? So we use one operation to compute also. You know that you can actually mix these things. So let's say add into polynomials. Now you see it just added those two polynomials. Now let me give you a bit about the mixing I talked about earlier. So let's say we want to now multiply by, or rather let's add by a decimal. right? Let's add by decimal. So you have, let's get decimal. Let's make this 4. So you have this. So this is it added the 4, which is a constant, plus this constant, which is how it should normally work. Now let's try something more interesting. Let's say I want to multiply this by a fraction. Now, ideally, if polynomial multiplication was on its own, you probably not be able to mix these two types. But now we're actually doing it here because it is supposed to be expressive, right? So let's say, let's make this 3 over 2 so that it's more interesting. So let's do 3 over 2 multiplied by polynomial. By this polynomial, we have, see, we have an interesting value, so, you know, so because, it's divided by 2 and every single thing here is divided by 2, so it just simplifies, you know. Now let's do something even more interesting. We want to use this polynomial as the power of like a decimal, right? Let me show you. So let's say we want to do 2 raised to power this polynomial. Let me take this up so it makes more sense. So let me give you power, and then you have, let me connect B, and then let's connect this. Now you see, this is an interesting operation, and now it might have thrown an error, but it doesn't want to throw an error because it knows that this is not a wrong operation, rather it's just a bit unintuitive. So it gives you in this form, right? It shows you that this is just 2 raised to power this. Now you can now still use this. Okay, you just see how this came out because this just shows you how everything works. Actually, um we're going to add a bit of labeling here for colors. We're using colors so it can be easier. This is going to be shipped like a bit after this video is published so that it can be easier for you to understand. But yeah, that's by the way. So let's try to do something like adding to this value, right? Because it's already a compound value, it's already a bit all over the place, but then it still would try to do computation because it doesn't want to restrict you from what you should do and what you shouldn't do. So you see, it's give you 2 plus this operation. So yeah, let's go to linear. So this is just linear, which is just a polynomial of degree 1, and then quadratic, which is just a polynomial of degree 2. And you can do all these things with quadratic, with linear, and so on and so forth. So yeah, thank you for watching today's video, and I'll see you in the next one. Thank you.